Hello guys, how are you doing? Welcome back again to this video. Let me trust you're doing good wherever you are. Today, I'd like us to discuss about the schematic. You want to understand what is a schematic, what does it does, and how you can interpret it to make your work easier while diagnosing a motherboard or while repairing a motherboard. And in this case, we are talking about the laptop motherboard. So first of all, we like to know what is the definition, what is a schematic, and what does it does. A schematic, this is a symbolic representation of a circuit diagram. In short, it's a diagram which shows the connection among the components in a laptop motherboard. Yes, that's the simplest term I can describe a schematic. It is it's a diagram which shows the connection among the components in a laptop motherboard. These components you're talking about are the components like capacitors, resistors, MOSFETs, power lanes, inductors, and all those. So it shows what are the measurements of these components or the values of these components, be it the resistance of resistors or the capacitance of capacitors. Yes, and all those. Again, it shows the functions of pins. Yes, we have pins among the ICs. They have what's called the pins. So it shows what pin does what and which pin connects to what. Again, it shows the signal flow and the voltage flow within the among the components. So we are going to use one of the examples of the schematic we have here to discuss the functions of the schematic. So allow me, just give me 1 minute to share the screen. So here is my screen. So I'm going to use one of my documents I have. I don't know which one. I have so many notes here. I believe I recently downloaded a certain schematic for a certain motherboard. Yes, you can try to use this one. So this is the schematic for Dell E5400. Yes, we are going to use the schematic for Dell E5400. And of course, we're just going to use this one. We're not going to go far ahead. So this is a piece of the diagram. So what happens in a schematic PDF, each page, we have a table of content here somewhere at the top. And that table of content, it shows you at which page you find which particular point. For example, at this where we are, I don't know which page is this. We are at about page 82. Yes, this is page 82. When you go at the top, when we go at the top, let's just leg us back a little bit to the top. You're going to see what is contained in the table of content. So here you have the description about the schematic. The schematics, this is the confidential, the model name EDC41, PCP number. So this is the motherboard part number. So the part number for this motherboard is LAGH91P. Now, these are non-crucial information at the moment. Then here at I believe we should have the table of contents somewhere. I don't know at which page. It should be at page 1 or page 2. Okay, maybe this one they never put it. But most of the schematics you have the table of contents at page 1 there, whereby it shows you on page 1 we have this component. At page this page we'll have this component. So let's go back to our first image which we had here. So we are going to use this page to discuss what you're going to discuss today. Let me zoom out a little bit. Yes. So this is a piece. This is a piece which shows what this is for what it is written here at the top. Normally it is indicated somewhere. Okay. Anyway, see this is a diagram which shows the power input. Yes, this is a diagram which shows the power input. And then here you have the power input connector. So this is the power port. You plug in your connector here. When you want to find a specific component or you need a specific item, for example, to access this MOSFET, this switch PQ09, you just come here and in the search, and then you write PQ PQ what? PQ9. Yes, PQ9. When you search PQ9, you'll have the switch here. So this is switch 1. Yes. So on the motherboard, you find these components are indicated. You will find if it is MOSFET 1, it is written there PQ1, or there's a certain code there. You just come here and type that MOSFET, that you will get the component, the location of that component. As you can see, the results I get here is 1/1. So it means this is the only PQ9 we have in this motherboard. So let's start from here. When you plug in here at the connector, it shows you at pin number 1 and 2. So we have the pin number 1 and 2. It shows NPT. So these are the signal lines. So these are the communication lines which goes into the SIO. So as you can see, pin number 1, it's going this way, and it goes up. It goes up. Then after there, it goes this way. Then you will have the first component through along that line, which is BD4. So this is the charging ID diode, BD4. Once you have your laptop not identifying your adapter, this could be this line, this entire line. I didn't say this is the only problem which could have been the issue, but this entire line could be the reason, because this is the line for communication. This line is the line which communicates with the SIO. Yes, and it also communicates with the processor, that is the PCH. So after the BT4, we have PL3. So this is the PL. So this is power inductor. When you see P, it means there's a power. Then L for inductor, P power, D for diode. So this is power diode number 4. This is power inductor number 3. So it means we have other power inductors and we have other power diodes. So after this power inductor, it goes here through this resistor. So this is the track so you see it shows the signal flow. At the same time, it shows the connection. So the connection between this BD4 and this PL are all along the signal line. Then after PL3, we are going to the next component, which is PR6. PR6, it means this is the power resistor number 6. And the power resistor number 6, the values for that resistor is 100 kilo ohms. So when you measure this, when you measure the resistance for this, you just have to use your meter in a resistance mode. Then you put your probes against the resistor. You put another probe this side. You put another probe this side. Then you will have 100 kilo ohms resistance. Yes, so matter resistance might have a different resistance, but this particular resistor, it will have 100 kilo ohms. That is why when you want to replace a certain resistor or a certain component, at least you need to know which value of that resistance or which value of that capacitor before you decide to replace. These are the coding, these are the writings which is here. This one shows the size of that capacitor. So this one is in terms of length and width. So it means 0.4. This is 4 millimeter by length and 2 millimeter by width. Then here, this percentage, it shows the error. So the error which you might get in the resistance, which is 1%. So it means if this is the resistor for, so this is the resistor for 100 kilo ohms. So it means I can either get 99 point something kilo ohms or 101 point something kilo ohms. Yes, it should not be less than 80 or more than 110 kilo ohms, because it will be more than 1% error. Yes, that is why you need to have this last value to represent the error of that resistor. So the relationship between this resistor and this diode, still they are all along this main power line. Again, this resistor is connected to this. through this line. And it is also this resistor, it connecting to this other component is also another switch. This is a BQ3, which is also connected to through this B line, this particular point. There is another resistor. So within the motherboard, you'll also find this resistor. This is PR8, which has a value of 15 kilo ohms. It has the same size as this one because it's also 0402. 0402. We said this is the size. This is 4 millimeter by 2 millimeter. This is length by width. And the 1%, this is the error you can get from this 15 kilo ohms. So as you can see, even though these resistors are equal, the same in size, but they are not the same in resistance. So it means what? You cannot replace this resistor with this resistor, even though they are the same in size. They're very tiny, so be careful. They're very tiny. You might think you can replace a certain resistor to a certain resistor. No, it doesn't work like that. Because you can see they have varying resistance. Even if they have the same resistance, again, they might be having a different what errors. Yes. Then apart from that, we have this other line which goes this way. Then you have PR3, and this PR3 it has a 0 ohms resistance. So this is 0 ohms resistance. Though they have the same size, they have the same size with this one. But this one, they have an error of 5%. So it means you could be having it as a 0.05, 0.5 and below. Yes. Then we have also another MOSFET. This is a BQ2. So this is another MOSFET which is still along that main signal line. And this MOSFET is connecting to another resistor here, PR5. And this resistor, it has 33 ohms. Can you see now the difference between this and this? This one was having 100 kilo ohms. This one, this K represent kilo ohms. This one was having 15 kilo ohms, but this one having 33 ohms. But still, they have the same size. So you can see the reason why it is good to understand and interpret the schematics, because we will know the value of this resistor. We will know the relationship between among these components, these resistors and these MOSFET. So it shows the relationship among the component, be it the MOSFET, the inductors, because you can see this inductor is also related to this MOSFET, which is related to this resistor, which is related to this power line, which is related to any other thing which is along that power line. Then past here, you can see 33 ohms, same size with a different error. So this one have 5% error. Yes. Now, I don't want to proceed. Okay, let me just explain this. Then after the output of this MOSFET, we will have that line going past this resistor of 33 ohms, which has 5% error. And then it branched here. Then to have another resistor, which check power going past here. And this is plus 3.3 voltage always. So this is the plus 3.3 voltage always, which goes into the SIO. And remember, we said the battery is communicating with the SIO through that line. Remember? Yes. So you can see this resistor, it has 2.2 kilo ohms, which is 2200 ohms. 2.2 kilo ohms, same size, but different error of 5%. And you see that? Yes. So the gate for this MOSFET, is also giving out information to the what? This information is going into the ICH, and the ICH controls all the inputs. So that's why we will have battery is one of the input we input into a laptop. So meaning this 5 voltage always is the line which communicates with the PCH. Now we are done with that signal line. Let's go back a little bit to the main power line. So you see this pin is the one for the signals. Then we have the pins for the power. So these are the pins for the power 432. These are the power pins. Then we have the pin number 6 and 7. This pin 6 and 7, you can see that here it is written ground. So those are the pins for the ground. These are the pins for the ground. So these ones are connecting to the ground. Now let's focus on the positive line. Here we'll have plus 19.5 voltage DC in jack. So this is the voltage which you supply into your laptop. That voltage goes through this line. It goes through this line. It goes through this line. Once it reaches here, you can see it goes past PL4. So this is power inductor number 4. Then even before there, it will also have a capacitor there. It will also have a very small capacitor there. This is PC5. P for power, C capacitor. So this is power capacitor number 5. Then these are also the information about that power capacitor. Yes, you have the size, you have the maximum voltage it can support. Then you have the measurement for that capacitor. And this, I believe, sometime you might be asking yourself, what are these? 1, 2, 1, 2. These are the pins. Yes, these are the pins or points. So this particular point of this inductor, this is pin number 1. Then the other side is number 2. So number 1 is always the input of that component. So here is the input for this inductor, then the output is the point number 2. Same case with these capacitors. As you can see, this is the symbol of MLCC capacitor. So again, you pay attention to the symbols. Sometimes they might not write for you the name of that component, but they just give a symbol. For example, this one, these are symbols of what? These are symbols of ceramic capacitor. That is why we say the schematic is a symbolic diagram, because almost each and everything here is written in form of symbols. Then you have another capacitor here, which is capacitor PC number 7. We said P represents power, so this is power capacitor number 7. It also has a value. The value for this is 0.1 farads. 0.1 farads. Size 0.04, that is 4 millimeter by length and 2 millimeter by width. Then the maximum voltage this one can support is 25 voltage. Then let's proceed. This is the line. This is the main power line. That's why it carries plus 19 voltage. Along the way, we have other branches. As you can see, here is another resistor. So this is the resistor PR13. PR13 with 4.7 kilo ohms. 4.7 kilo ohms. 8 millimeter by 5 millimeter. So this is a little bit bigger than the rest. So this is bigger than this one. It's almost double this one because 4, this one is 8. So this is 4 by 2. This is 8 by 4. You can see. But this one has an error of 5%. This one has an error of 5%. No, we are not comparing capacitor with the resistor. Let's use this one. Sorry guys for that. So you can see this one is 8 by 5. This one is 4 by 2. You can see this one is double this. So along the main power line, we also have branches of other things like these resistors, filtering power for checking power flow, and all those communication lines. So here we also have another resistor. This other resistor with 1 ohm, 1 mega ohms. This M represents mega, so this is 1 mega ohm with 4 by 2 millimeter, and then error of 5%. This is a MOSFET, and also we have the information about that MOSFET, which goes back also to connect to another cycle of resistors. And this also are the one which goes into the 3.3 VDD DC. Yeah? So that's the communication line for the input line. Now let's go directly here. This is the first switch which receive power in the motherboard. So you see the main power is coming this way. Though we have other filtering components like the capacitors, resistors. Then we have uh, here we have the first switch. This is the first MOSFET. PQ. Q represents transistor. So this is power MOSFET. It is written number 9, but generally it is always the first MOSFET. That's why we call it MOSFET 1. And you can see this one, they named it as 1 for switch number 1. You can see this one, it receives power in the source. So these three pins are the source, and all of them are connected together. That you have the gate. whereby the gate is connecting to this resistor, which is connecting to this other tiny MOSFET, which is connecting where? Which is going back here, is connecting to this particular point, this other transistor here. Yes, you can see all of this. So this 3.3 voltage is the detection line. This place whereby they place a blue something. So this one represents the pad, is the testing points. You can also disconnect by removing the solder because these are the joints. Uh, they're just solder which has been placed there. You can join those points. Let's go back here. After the first MOSFET, the power is switched to the drain, whereby the drain have all four pins connected together and the power proceeds. That's why you can see we have 19.5 voltage in. The same power is still proceeding to the second MOSFET, 19.5 voltage in. And under the second MOSFET, that's why they named it S2. S2, which represents switch number 2, or the MOSFET 2. This is labeled PQ4. This is power transistor for number 4, or power MOSFET number 4. And the MOSFET before, there's another video I made about the MOSFETs. And I discussed so many things about the MOSFETs, how to measure, how it works. And the MOSFET in full, we said it is metallic oxide semiconductor field effect transistor. That's the full name for a MOSFET. So in short, that's a transistor. Then this second MOSFET, you can see how it switches power. It switches power from the drain into the source, whereby the source sends power into the motherboard. Then you have the gate connecting to another resistor of 49.9 kilo ohms, size 4 by 2 millimeter, error 1%. So these are the signal lines which is used by the charging IC to control these switches. As always, the gates of MOSFET are the signal points. They are the signal lines which is used by the control IC to control those switches, those switches. After the source of the second MOSFET, as you can see, the source is connecting to another resistor. And this resistor has 499 kilo ohms of 4 millimeter by 2 millimeter, 1%. So I believe by now at least you've seen the difference. Even though these resistors are the same in size, but they have a different values. That is why it doesn't make sense. Sometimes you replace a certain resistor with a certain resistor, and you find that it's not working. Yes, and also if you're not careful enough, you might create other problems. You might create other problems. For example, if this resistor or if a certain resistor you are replacing is connecting to a sensitive place or a sensitive component. For example, let's say it's connecting the component for the what? It's connecting the component for the CPU or for any chipset. You'll find that whichever the resistor you put there, it might release more current, or it might allow more current to pass through, or it might allow less current to pass through. Yes, if it allows more current to pass through, you'll find that it will create a short to that sensitive component. Then after here, the voltage is allowed to the phase 2 of the motherboard. So this was what's called the phase 1 power supply. Yes. So after here, the voltage now is sent into the motherboard. So you can see before the voltage is allowed to go into the motherboard, it goes through a lot of things. It goes through a lot of issues. Yes. And this is how you interpret the schematics. You can see the resistors VR17 with 100 kilohertz. So you cannot use this component, even though they have the same size, but they have different errors and different values. This resistor you cannot replace with the resistor which is where? Let's check another resistor. Yes, for example, this. You cannot take this. This is a mega ohm resistance, and the other one is 100 kilo ohms. Let's use this because the other one is far away. Can you see? This is a resistor. Though they are the same in size, but this one has an error of this one is 100 kilo ohms. This one is 1 mega ohm. They are not the same resistance. So these ones maybe they might have insignificant changes, but if the component which is uh, if the component which is after this resistor, where this resistor is supplying power to, is a very sensitive component, you might find that component will experience some difficulties. So guys, let me hope at least you've understood something about the schematics and how to read it, how to understand these values. We say the schematics shows the connection among the component in a motherboard. So as you can see, the connection between this and this, or the connection between this and the power port, for example, or the connection between this and the signal flow. So after here, this arrow the points at the direction of which the current or the signal is going. Yes, the arrow points at the direction in which the signal or the voltage are going. For example, let me just give you a very small example here. Let me believe I have an IC somewhere. This is back connector, that is the further connector. I want us to see an IC, for example. Let's say you have a particular IC. Can you use this? Let me hope this one will have. No. This one cannot. I want me to show you one example of a specific IC. I don't know where is it. Whereby you find that any signal, you being showed the direction of which the signal is flowing. If it is flowing in or flowing out, even this one, you can see this IC. Here is a particular IC, the connector. This is CPU XDP connector. As you can see, you can see these arrows. Okay, let me use a single one. Maybe those ones are very confusing. Those ones are somewhat confusing. You know, I don't want you to be confused. It's too early. Yes, as you can see, even this one. This arrow, it's pointing in. So it means whatever is flowing along here is going this direction. It shows the direction of which either signal or the voltage is flowing. But this one is pointing out. So it means whatever flowing along this line is coming out from that. You can see this one. SIO power pattern, it's going out. So it means this one is connecting to the power pattern. Then we have others which are not showing any directions like this. So maybe these ones are not connecting to anywhere. Maybe those ones are not connecting to anywhere. Yes, and the arrow, they could use arrows like this, or they can use some things like this, or they can use something else like this one. Let me use this. Let me use this schematic, for example. Can you check this? Uh, let me up. I have whatever I'm interested in showing you here. Yes, I got it. I got it. Can you see this? Let me just zoom it out a little bit. In fact, these ones they have integrated for you. When you see this arrow is pointing out. So in fact, they have indicated for you out, out, because it's coming from this place, coming out. This one you've been shown going in. So whatever is flowing here, it's going in through the gate. Then it goes out to either drain or source. I don't know, wherever the direction, wherever it's going. Yes, if you have an IC, for example, this is an example of an IC. This is ICU 6200. This U 6400. Can you see this pin? They haven't indicated, but this is BP back. This is a voltage coming from the battery. So it comes that way. In fact, they have written for you fee in for voltage coming in. That voltage coming in, then it goes through pin number one. So the pin number one for this IC is the input pin. Pin number one is the input pin. Then we love now. So this is the VDD. This is the operating voltage for this chip. Then we have pin number two. Pin number two, which is connected to pin number 12. Can you see it? Even the schematics, they don't pay attention to the pin number of the pin. So they just give you the relationship between the pins or among the components. Even the structure of an IC is not does not have the layout there, the physical layout of the board or the physical layout of the component. As you can see, this IC it's like a rectangular in shape, but in the real sense, this is a squared IC. So pin number 2 and pin number 12 are all LX and they are connected together. And these pins is the VRP5 5VO pH, which is also connecting to pin number 13. And these pins are connected through this inductor, connecting through this inductor. Pin number, this is the input of this inductor, the output number 2. Along that inductor, we have the filtering capacitors of different values, 22 farads, microfarads, 22 microfarads. So can you see these capacitors are all the same? You have MLCC's capacitors, these ones, MLCC capacitor, MLCC capacitor, MLCC capacitor. But that one, this is a symbol of a different capacitor. Can see flat, here is flat that appended something there. You have just polarities. So it means this is a chemical capacitor. So here, the final part, you have a chemical capacitor. And the line proceeds, and you've been shown it's out. So it means this line is output. So these lines are output. Yes, these ones are output. This is the LDO line, output going that way. This one is input, USB 5 voltage input. So this one is coming from the USB. It comes through this resistor of 0 ohms, 5% error. Then it goes in. So this is the enable line. So this is enable 1. And they are also connected to pin number 5, enable 2. That's why you can see enable 1, number 6, enable 2, that one. Then you can see all of these are coming in. So this is enable 5 coming in, which is connected through as this resistor, whereby point 1 of this resistor is connected to that line, when the other point is connected to the ground. So this is the sign for the ground. So pin number 3 and pin number 13, as you can see here, pin number 3 and pin number 13 are all together and they are connecting to the ground. So meaning if you are measuring that IC, pin number 3 and 11, they should be connected to the ground. No other pin is connecting to the ground. You can see this one is power good pin, which are going out. Yes, you can see these pins, all of them, they have a certain descriptions about it. Yes, this is another IC. This other IC also you have pin number 1, voltage in. Yes, you have the voltage in, and this voltage in is coming from PV battery. Then it goes into that IC. Here, pin number 2 is the ground. Pin number 2 is the ground, and in fact, it is indicated that we have other signal lines. V out, it means the voltage out. Since we had V in, voltage in, this is V out. Then you have the LDO line. LDO line, they going this way, then going out. So guys, let me hope you're getting something out of these discussions. So guys, thank you so much. Let me hope at least you've understood something. Yes, the discussion was a little bit longer than I expected, but we did it. So I did imagine the video will take us more than 30 minutes, and I can see we've taken about 34 minutes. So guys, thank you so much. Thank you so much for being patient. Thank you for listening to me. And We shall see each other in the next video. Yeah, we shall see each other in the next video. And please, I'm still reminding you, in case you haven't subscribed to our channel, please, guys, I'm still requesting you, please subscribe so that we can grow this family together. Yes, I am happy when I see a new subscriber, and I am happy when I see the already members which are already our subscribers. Again, guys, in case you have an issue with your laptop, or in case you have any problem with your laptop, you can just contact us. You can visit us. Then we see how we can help you. We might be able to help you, or we might not. But we always try our best to make sure our customers are satisfied. So if you know someone still who has a problem with your laptop, you can also connect them to us. And still, if you want to learn about laptop repairs, if you want to study to repair laptops, you are also highly welcome. My contacts are in the bio. You can just reach me out. Then we can discuss the logistics and anything else. So, guys, thank you so much. Please don't forget to subscribe and see you in the next video. Goodbye.